Consumers don't have to give up their favorite vehicles, and Magna is once again at the forefront of tech leadership.
In a move set to redefine electric vehicle performance, Magna International, the renowned Canadian auto parts manufacturer, has unveiled an innovative electric motor that promises to deliver unparalleled efficiency, power, and agility. Designed with a sleek, lightweight frame, this cutting-edge motor not only offers a substantial boost in energy efficiency, but also elevates the power potential for electric vehicles. This is a big deal, as it may all but transform industry standards for good. It would not be an exaggeration to say that this new EV motor will become the god of electric cars. There's a lot to unpack, so let's get started. Magna and its role in the automotive industry. Headquartered in Aurora, Ontario, Canada, Magna International is among the largest suppliers of automotive parts worldwide, with a sprawling portfolio that encompasses everything from powertrains to advanced electronics and complete vehicle assemblies. Over the years, Magna has built a reputation for reliable, cutting-edge solutions that major automakers rely on to enhance their vehicles. As the automotive industry shifts increasingly towards electrification, Magna has adeptly transitioned from producing conventional components to pioneering the next wave of EV technologies. So, how big of a deal is it? Will Magna truly revolutionize the EV industry? Well, let's find out. The company collaborates with leading brands like Mercedes-Benz, BMW, Ford, and General Motors, tailoring its engineering expertise to meet each manufacturer's unique demands. Magna has also played a crucial role in the burgeoning EV sector, providing not just components, but holistic solutions that support and elevate the efficiency, power, and performance of electric vehicles. This transition marks a deliberate pivot from traditional auto parts toward a focused emphasis on electric drivetrains, battery systems, and lightweight construction. As the automotive world races towards sustainability, Magna has leveraged its extensive experience to influence the design and functionality of various EV models. This influence extends across a spectrum of electric and hybrid vehicles that incorporate Magna's advanced components, from battery enclosures to specialized e-drive systems. One of Magna's notable collaborations is with Jaguar, for whom it has produced the F-Pace and I-Pace models. The I-Pace, Jaguar's first all-electric SUV, particularly benefits from Magna's engineering precision, incorporating sophisticated powertrain components and efficient assembly practices that have helped it make a strong mark in the EV market. Magna's evolution into a leader in EV powertrain technology is perhaps best represented by its innovative e-drive powertrain systems. These systems are designed to maximize efficiency and adaptability, allowing automakers to streamline their EV production processes without compromising on quality or performance. The e-drive system, which integrates electric motors, inverters, and software controls, addresses the need for scalable, modular powertrain components that can serve multiple models without extensive customization. Before we move on to the technical aspects of this latest technology, let's get some context about the company that made it all possible. Magna International, the next big player in the EV market. Established as a modest tool and die operation by Austrian immigrant Frank Stronach in 1957, Magna has evolved into one of Canada's largest and most impactful companies, with a robust presence in both North American and global markets. From its early beginnings in a rented garage in Toronto, the company has grown to achieve a prominent position on the Fortune Global 500 list for over 2 decades and consistently ranks on the Forbes Global 2000 list as one of the world's most successful and influential enterprises. Today, Magna boasts a formidable workforce of 158,000 employees spread across 342 manufacturing facilities and 91 engineering and sales centers in 27 countries. Magna's corporate governance is rooted in a unique fair enterprise system that integrates employee profit sharing and equity participation. This distinctive approach, embedded within Magna's corporate constitution, ensures that profits are shared equitably among employees and shareholders. After securing its first major contract with General Motors in 1959, Magna grew steadily, establishing a network of plants across North America by the late 1960s. In 1969, the company went public through a merger with Magna Electronics Corporation, an aerospace and defense entity. By 1973, the newly rebranded Magna International focused intensively on the automotive sector, while maintaining its foray into aerospace and defense for several years. However, in 1981, Magna divested from its aerospace operations to concentrate exclusively on automotive systems and parts. During the 1980s, Magna expanded into Asia and restructured its primary business divisions into autonomous, publicly traded entities. This move not only accelerated Magna's global footprint, but also allowed its core automotive sectors to operate with increased agility and innovation, tailored to the demands of specific regions and client needs. Today, Magna is at the forefront of automotive innovation, providing groundbreaking solutions in the areas of electrification, lightweight construction, and advanced driver assistance systems. Its commitment to research and development has solidified its position as a trailblazer in the shift toward electric and autonomous vehicles. Magna International's forward-thinking innovations have consistently placed it at the cutting edge of automotive technology, beginning with its early development of automotive rear-view cameras in 2005. Magna started producing rear-view cameras for Hummer models at its Michigan facility, marking it as one of the first automotive parts suppliers to introduce such technology at scale. By 2007, Magna's rear-view camera technology had proven so impactful that the company secured a significant contract for 350,000 units. To meet the surging demand, Magna later opened a specialized plant dedicated to manufacturing cameras and advanced driver assistance systems, and has since produced more than 46 million of these components, transforming vehicle safety standards worldwide. This recent foray into the EV industry is not the first time that Magna redefined industry standards. It has done so before and is about to do it again. The company's influence expanded further in February 2015 when Samsung SDI acquired Magna Steyr's battery pack division, an Austrian unit of Magna. This divestiture allowed Magna to reallocate resources and explore new technological frontiers in automotive innovation, particularly around autonomous driving and cybersecurity. Recognizing the growing importance of vehicular cybersecurity, Magna partnered with Argus Cybersecurity in 2015, securing access to Argus's sophisticated security technologies that would help safeguard connected and autonomous vehicles against cyber threats. In March 2018, Magna's ambitious vision for autonomous driving took a significant leap forward through its partnership with Lyft, the popular ride-sharing platform. Magna's $200 million investment in the collaboration aimed to develop advanced self-driving kits capable of converting standard vehicles into autonomous ones. As part of this arrangement, Magna became Lyft's exclusive supplier of self-driving technology, and both companies held joint ownership over the resulting intellectual property, marking a major step in bringing autonomous ride-sharing closer to reality. Magna's commitment to electric vehicles was further solidified in 2018 through a partnership with China's BIC Group to create next-generation smart EVs tailored for the Chinese market, one of the fastest-growing regions for electric mobility. Magna's expansion within the EV sector continued to accelerate in February 2021 with a new manufacturing facility in St. Clair, Michigan, focusing on producing battery enclosures for the 2022 GMC Hummer electric pickup. This $70 million facility not only advances EV infrastructure, but also generates over 300 jobs, reinforcing Magna's commitment to fostering local economies while championing sustainability. Production at this facility complements General Motors' Detroit and Hamtramck locations, where the actual battery assemblies are constructed. Looking forward, Magna's partnership with Ineos to develop an electric variant of the rugged Ineos Grenadier off-road vehicle reflects its ongoing dedication to broadening EV accessibility. The vehicle, which is set for production in Graz, Austria in 2026, epitomizes Magna's balanced approach to applying advanced technology to both consumer-centric and specialty vehicles. With its unparalleled versatility and deep-rooted expertise, Magna remains at the forefront of contract manufacturing and automotive innovation. By adapting to new technologies, including including electrification and autonomous driving, and catering to the unique requirements of each vehicle, the company has firmly established itself as a major player in the automobile industry. This technological excellence and height of ambition is best reflected in Magna's Mila series. Mila, which is short for Magna Innovation Lightweight Auto, embodies the company's cutting-edge approach to automotive design and sustainable technology. It is a line of innovative concept vehicles that showcase advancements in lightweight materials, alternative powertrains, and versatile automotive architectures. The Mila journey began with the original Mila concept, introduced at the 2005 Frankfurt International Motor Show as a sleek one-seater sports car prototype. The Mila concept established the brand's focus on lightweight construction and fuel efficiency. The first prototype arrived in 2006, soon followed by the Mila 2, a two-seater version that extended the design's versatility and appeal. Building on these foundations, Magna unveiled the Mila Future at the 2007 Geneva Motor Show. Rather than a fully functional vehicle, the Mila Future was a sculptural exploration of design, offering 4 distinct roof configurations: coupe, landaulet, coupster, which is a hybrid between a coupe and a roadster, and roadster. The Mila Alpine, introduced at the 2008 Geneva Motor Show, was built as a rugged 4-passenger off-roader with a rare 3+1 seating layout and mid-engine configuration. In 2009, the Mila EV was revealed as a modular electric concept at the Geneva Motor Show, marking Magna's first foray into fully electric mobility. Built on a highly adaptable lightweight platform, the Mila EV provided insights into how electric drivetrains could seamlessly integrate with Magna's modular designs. The Mila Aerolite, presented at the 2011 Geneva Motor Show, took the lightweight philosophy further with a compact 4-seater design powered by CNG. Expanding the concept further, the Mila Coupe was introduced in 2012. Unveiled as the 6th Mila prototype, the Coupe featured an ambitious design that allowed it to function as 3 distinct vehicle types: an SUV coupe, a pickup, and a convertible. The Mila Blue, a highlight in Magna's portfolio of eco-conscious designs, is a lightweight natural gas-powered vehicle that achieves a remarkable reduction in emissions, producing less than 49 grams of carbon dioxide per kilometer. The Blue concept car exemplifies the brand's focus on extreme weight savings, achieving a reduction of 300 kilograms compared to typical A-segment vehicles. In 2015, Magna introduced the Mila Plus at the Geneva Motor Show, blending high performance with sustainable technology in a lightweight hybrid design. The Mila Plus features a fully electric range of 75 kilometers and a total weight of 1,520 kilograms, with a carbon dioxide emission rate of just 32 grams per kilometer. Designed to deliver both driving enjoyment and eco-conscious performance, the Mila Plus represented Magna's forward-looking approach to combining alternative power sources with advanced lightweight engineering. What is clear, though, is that each Mila concept has demonstrated Magna's expertise in developing flexible, environmentally friendly solutions that push the boundaries of automotive technology. Each vehicle in the Mila lineup offers a glimpse into the future of sustainable transportation, reinforcing Magna's role as a pioneer in vehicle engineering. This time, Magna has come up with something big. Well, not big in terms of size, but massive in terms of impact. Magna's new electric motor. Magna International has made headlines yet again by securing a contract to supply a sophisticated primary rear e-drive system for a high-end vehicle platform from a North American-based original equipment manufacturer. The e-drive solution chosen for this project is a variant of Magna's advanced 800-volt EDS Duo, designed to push the boundaries of efficiency and power. With outputs reaching an impressive 726 kilowatts and 8,000 newton-meters of torque, this system integrates 2 powerful electric motors, 2 high-efficiency inverters, and dual gearboxes into a singular compact package. This unique configuration enhances power density and reliability, tailored specifically for the demands of luxury electric vehicle platforms. In this project, Magna is responsible for critical design elements, including the gearbox and housing, advanced cooling mechanisms, and the seamless integration of the e-motors and inverters. Each component is carefully engineered to ensure optimized performance, continuous power levels, and long-term reliability. Magna also unveiled its latest iteration of the 800-volt e-drive technology in January at CES 2024. This next-generation drop-in solution integrates a suite of technological enhancements, resulting in meaningful gains across weight, size, efficiency, and sustainability metrics. By focusing on weight reduction, Magna's eDrive boasts a 75-kilogram design with a height reduction of 20% over previous models. Notably, the eDrive achieves up to 93% real-world efficiency across various driving conditions, including the worldwide harmonized light vehicles test cycle and highway tests. This efficiency benchmark not only optimizes energy use, but also translates to improved driving range and performance consistency across a range of vehicle speeds. One of the standout innovations in Magna's new eDrive is its unique rotatability, which allows the unit to rotate 90 degrees around the drive axis. This enhancement represents an industry first in eDrive flexibility, making the system adaptable for either front or rear placement within vehicle architecture. This feature provides original equipment manufacturers or OEMs with greater versatility during assembly and facilitates optimized integration within various vehicle designs, particularly for EVs targeting a premium or performance-oriented market. Furthermore, Magna has made significant strides in sustainability, including material innovations that reduce environmental impact. By minimizing reliance on aluminum and heavy rare earth elements, Magna has managed to cut carbon dioxide emissions during production by approximately 20% compared to previous eDrive iterations. The new 800-volt eDrive is designed with versatility in mind, capable of serving as either a primary or secondary power unit with an optional e-decoupling unit, which enhances energy efficiency by disconnecting the drive when not needed. This adaptability makes it suitable for a range of vehicle classes. With peak outputs of 250 kilowatts and 5,000 Newton-meters, this next-gen eDrive can meet the performance demands of diverse EV applications, from daily commuters to high-performance luxury models. The new fourth-generation eDrive builds on significant engineering milestones while entering an advanced testing and evaluation phase. This version not only boasts remarkable improvements in performance, but also addresses sustainability through a redesigned cooling system. This innovative internal cooling mechanism maintains the motor's magnet temperature at lower levels, allowing the eDrive to function efficiently with fewer rare earth materials. The shift toward minimal resource use and enhanced material efficiency is integral to Magna's environmental initiatives, as the company aims to lessen the environmental footprint of its manufacturing processes. While the eDrive retains its familiar 3-in-1 design, with a motor, inverter, and gearbox, every element within this setup has been extensively re-engineered. This upgrade is an evolution of every aspect from the third-generation technology. Most notably, power density has increased by an impressive 60%, and torque density has seen a 50% improvement. This leap in efficiency allows the next-gen eDrive to provide higher power output within a lighter and more compact unit. The collaboration with LG Electronics has been a driving force behind these technological upgrades. One standout feature of this partnership is the redesigned hairpin synchronous motor, which integrates an internal permanent magnet or IPM design. Unlike traditional motors, this configuration embeds the magnets directly into the rotor, enhancing both efficiency and durability. This new design minimizes losses within the motor, translating into improved overall efficiency. The IPM motor also offers notable weight and size reductions. By optimizing the motor's geometry and the magnetic structure within the rotor, Magna has succeeded in creating a lighter motor without sacrificing performance. This weight reduction aligns with broader efforts to make EVs more energy efficient and reduces production costs as well. Magna's latest eDrive technology showcases a remarkable leap in flexibility and efficiency. Most notably, the ability to rotate the eDrive unit around its drive axis grants manufacturers a highly adaptable component that can seamlessly fit both front and rear orientations of a vehicle. This flexibility means OEMs only need to validate a single drive system for both positions, yielding a significant cost advantage. This flexibility can save anywhere between $50 and $60 million in validation costs. At the heart of this versatility lies an active fluid control pump, ingeniously positioned at the unit's base to ensure optimal fluid flow regardless of orientation. This pump, with its precisely engineered valve control, adjusts fluid circulation to meet varying demands, from high-speed, low-torque scenarios to intense low-speed, high-torque applications, such as towing or moving fully loaded vehicles. Cooling requirements escalate in these latter conditions, especially for the motor's magnets, which can overheat under strain. To address this, Magna has engineered a unique cooling mechanism that redirects fluid flow to target the magnet's volts directly. This has never before been achieved in this manner in e-drive systems. Thanks to this advanced cooling system, Magna has successfully eliminated the need for terbium, a particularly heavy and environmentally damaging rare earth element. The company has also reduced the use of dysprosium from 1.1% to just 0.5%. This shift reflects a substantial environmental improvement, reducing reliance on these nasty chemical products. By combining structural flexibility with pioneering cooling solutions, Magna's new e-drive provides a forward-looking blueprint for electric powertrain systems that don't just elevate performance, but also actively reduce environmental impact. This blend of engineering adaptability, cost efficiency, and sustainability cements Magna's commitment to driving transformative change in the EV industry. But that's not all. The latest iteration of Magna's e-drive system takes a significant leap with a voltage upgrade from the previous 400 volts to 800 volts. 800 volts is poised to become the standard, offering an optimal balance between performance, durability, and efficiency. While some companies have explored even higher voltage levels, such as 900 volts, manufacturers must be cautious against pushing the boundaries too far. The industry's established norms for 400 volts and 800 volt systems are designed to ensure the longevity and reliability of the components. In 400 volt systems, components are rated for 600 volts to manage potential voltage spikes, while in 800 volt systems, components are rated up to 1200 volts for the same purpose. So pushing beyond 800 volts could jeopardize these protective measures and lead to reliability issues, reduce comfort, and compromise warranty coverage for consumers. A major innovation in the new e-drive system is the integration of silicon carbide chips directly into the printed circuit board or PCB through a process known as high voltage embedding. This advancement eliminates the need for a traditional module along with its bulky interfaces and bond wires, streamlining the system's design. The integration of silicon carbide chips also brings notable improvements in the system's cooling capabilities and operational efficiency. The new design allows for cooling from one side of the PCB, enhancing the system's ability to dissipate heat more effectively. This innovation not only improves the switching losses, which is the energy lost during the transition of power between components, but also results in better overall system efficiency. This increased efficiency translates directly into improved driving range for electric vehicles, making the e-drive system perfectly practical. The company has also raised the overall efficiency of its gearboxes from 91% in the previous generation to a remarkable 93% in the new system. This improvement may not seem like much in percentage terms, but it is a significant milestone. After all, even small gains in efficiency can have a substantial impact on the driving range of electric vehicles. A typical single-speed unit, which is the standard for most electric vehicles, delivers a consistent amount of torque across a wide range of speeds, eliminating the need for multi-speed transmissions like those traditionally used in combustion engine vehicles. However, some high-performance EVs, such as the Porsche Taycan, use two-speed transmissions to better handle the dual demands of high-speed driving and high torque at low speeds. For such applications, Magna has developed a two-speed gearbox for one of its customers, aiming to provide a vehicle capable of reaching speeds up to 130 miles per hour while still delivering a massive 15,000 Newton-meters of torque, suitable for towing heavy loads like a trailer. This specialized e-drive system is an example of how Magna is customizing its technology to meet the diverse needs of the electric vehicle market. So it's not an exaggeration at all when some industry experts are calling Magna's next-generation e-drive system the god of electric car motors. These units will be manufactured in Ramos, Mexico. The continued development of both single-speed and multi-speed gearboxes highlights the company's commitment to advancing electric vehicle powertrain technology, ensuring that their systems can meet a wide range of consumer and industry needs. But if you're still not convinced, let's see how much of a difference Magna's e-drive system can make. Enhanced performance and efficiency. The e-drive's improved voltage system allows for a dramatic increase in charging speed, effectively doubling the rate at which an EV can charge compared to older 400-volt systems. The 800-volt setup allows for faster energy transfer, which translates to less time spent at charging stations and more convenience for drivers. Moreover, with the increased voltage, the system can push more power into the battery in a shorter amount of time, making long-distance travel more viable and reducing range anxiety. But that's not all. The new eDrive system also boasts an impressive 93% efficiency, which means that this much electrical energy from the battery is converted into usable mechanical power to drive the vehicle. This stands in stark contrast to traditional internal combustion engines, which typically operate at an efficiency rate of around 20 to 30%. In traditional internal combustion engine vehicles, much of the energy produced by burning fuel is lost as heat, making these engines far less efficient. By comparison, Magna's eDrive ensures that the majority of the energy stored in the battery is effectively utilized, resulting in more mileage per charge and reduced waste. This higher energy efficiency not only improves the overall performance of the vehicle, but also enhances the driving range. Moreover, the enhanced design of the electric motor minimizes heat generation, addressing one of the key challenges in electric powertrains. Heat is a natural byproduct of electrical energy conversion, but excessive heat can degrade the performance and lifespan of the motor and other critical components. Magna has implemented a cooling solution that ensures lower operating temperatures, which is vital for maintaining durability over time. Traditional gasoline or diesel engines require complex mechanical systems such as transmissions, fuel injectors, exhaust systems, and cooling units to manage power emissions and fuel efficiency. In contrast, electric motors operate with far fewer moving parts, which not only improves reliability but also reduces the likelihood of mechanical failure. The new eDrive system enhances energy conversion by a significant margin, resulting in an additional 3 to 5% increase in driving range. This seemingly modest improvement can make a substantial difference for drivers, particularly in scenarios where longer trips or extended driving is required. The motor's high efficiency means more of the battery's energy is converted into useful propulsion, ensuring that fewer charging stops are necessary over the course of a journey. When combined with other factors like improved battery chemistry and software optimizations, this boost in motor efficiency significantly extends the vehicle's operational range, making EVs more competitive. Moreover, by reducing the overall weight of the motor and its components, Magna has made significant strides in optimizing the balance between performance and efficiency. A lighter drivetrain requires less energy to operate, which directly translates to reduced energy consumption and, in turn, a longer range per charge. Additionally, the reduced need for complex and bulky cooling systems means that energy otherwise spent on managing heat is now used more efficiently for propulsion. This reduction in cooling demands, coupled with the lighter system, contributes to an additional 10% increase in range. Magna's new eDrive system also features enhanced charging speeds, reducing the time required to recharge the vehicle's battery by approximately 50%. With the increased voltage in the system, combined with more advanced power management strategies, the charging process becomes faster and more efficient, allowing drivers to spend less time at charging stations. This reduction in charging time is crucial for mass EV adoption, as it makes long-distance travel and quick refueling on the go much more feasible. By halving the recharging time, Magna's technology effectively addresses one of the primary limitations of electric vehicles. The compact eDrive motor design also offers significant potential benefits in terms of interior and cargo space. Traditional internal combustion engines are bulky and require large engine compartments, reducing the available space for passengers and luggage. By contrast, electric motors are much smaller and can be integrated into more compact spaces within the vehicle. This efficiency allows automakers to design vehicles with more cabin space, more room for passengers, and larger trunks or storage areas. Together, these technological advances make the new eDrive system a game changer for electric vehicle manufacturers and consumers alike. However, like all technological advancements, the adoption of 800-volt systems brings with it both immediate and long-term financial considerations for automakers, while also influencing the cost structure for consumers in ways that can redefine the EV market. For manufacturers, one of the most notable financial benefits of adopting 800-volt technology is the reduction in system complexity and the cost-saving potential that comes with higher power efficiency. The increased voltage allows for faster charging and better energy management, meaning manufacturers can design vehicles that need less time on the charging station station and potentially rely on smaller, more affordable batteries for the same range. With a reduced need for oversized charging components, the overall cost to produce an EV can be lowered. Additionally, the ability to standardize components across multiple platforms, whether for front or rear-wheel drive, can further reduce validation and testing costs. On the consumer side, the financial benefits are equally promising. While the initial adoption of 800-volt technology could lead to slightly higher vehicle prices, the long-term savings could offset the initial price premium. The improved energy efficiency offered by the 800-volt system, coupled with faster recharging capabilities, means consumers will benefit from lower operational costs over the lifespan of the vehicle. Faster charging times reduce the likelihood of needing to use high-cost fast charging stations as frequently, and the higher voltage can extend battery life due to the more controlled and efficient energy delivery process. As a result, consumers can not only save time, but also reduce their overall cost of ownership. This will make electric vehicles more financially viable. In the broader context of the EV market, the 800-volt technology is already catching on. Porsche's Taycan, for instance, has become a benchmark for high-voltage systems in electric performance vehicles, using an 800-volt architecture that enhances charging speed and overall performance. The Taycan's 800-volt system allows for ultra-fast charging, capable of adding up to 100 kilometers of range in just 5 minutes, thanks to its high-power system. For consumers, this means less downtime and a more practical experience, especially on longer road trips. However, while the Porsche Taycan and other high-voltage systems in use today offer cutting-edge performance, they also come at a premium cost. What Magna is trying to do in terms of marketing is pretty simple. It is not only setting a new standard for efficiency, but also providing a more scalable solution for broader EV adoption across multiple segments. The shift to 800-volt systems signals a greater industry-wide push toward faster charging and longer range at more competitive prices, meaning that over time, consumers can expect better value in their EV purchases. A couple of years from now, this innovation will be seen as a transformative step. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.